Okay, a very good afternoon. Assalamu alaikum warahmatullah. This is Dr. Abdurrahman from B.S. Abdurrahman President of Science and Technology. I'm making a presentation on the current advances and challenges of environmental friendly green composites. It's a review. And so we all know that the growing concern about environmental damage and the inability to meet for more versatile and environmental friendly materials has sparked increasing attention in the polymer composites derived from renewable materials and all the biodegradable plant-based materials, especially from the forests. Right. So these composites are mostly alluded to as green materials. And most importantly, we have to consider that the main purpose of this focus on this paper, mainly focus on the green composites processing using a variety of naturally available resources, sustainable materials which are not detrimental to the environment, and new scientific signs of progress in achieving green sustainable development as well as nanotechnology and its environmental consequences. And additionally, the environmental impacts, if you see, of different composite materials are examined in this paper, along with their production from eco-friendly materials. Moreover, even the manufacturing aspects of the green composites and some concerns related to their production are also discussed, and even the merits of the green composites. So that is something that is going to revolutionize the way manufacturing is going to take place. That is also covered. And even the merits of the green composite materials with valid reasons why they are a valuable substitute for the traditionally used composite material are also covered. So to render them affordable, we all know that, and even sustainable and eco-friendly. See, many studies have suggested developing biodegradable green composites utilizing renewable resources such as natural fibers. Right, like I said, the natural fibers, you have the agro feedstocks and biodegradable polymers. As you can see on your screen, these are the wonderful properties. Like it has very good toughness, high stiffness, even easy processability. Even it is cost competitive when compared to the traditionally used composite materials based on the metal matrix composites. So what is the aim and objective? I think this portion already I have covered. And when you say green composites, this is how it is divided. One is the reinforcement, matrix, and filler. So based on three classification, you can see the reinforcement is classified into a natural fiber and hybrid fiber. And we have the natural fiber plus the natural fiber, and the natural fiber plus the synthetic fiber. Whereas in the case of the actual matrix, we have the synthetic matrix and the biopolymer matrix. And among the synthetic matrix or petroleum-based materials, you have the virgin, the recycled, blended. And even if you come to the last one, that is the filler part, we have the nanoparticles. There is nanoclays, graphene, carbon nanotubes, and cellulose crystals. And when coming to the various production techniques, these are various production techniques that are followed, adopted for the manufacture of green composites. So you have important techniques like the pultrusion, you have the compression molding, injection molding, resin transfer molding, extrusion, thermoforming, and filament molding. So when you see the green composites manufacturing, have indeed actually the green composites have indeed been designed to establish the composites that are very environmentally beneficial. So most are either entirely biodegradable or moderately biodegradable materials. So even the recent advances in the production of entirely biodegradable green composites, such as a starch and wood fiber composites, as well as the soy protein-based composite materials with organic fibers, have showed tremendous qualities. So this is how you can see the sustainable reinforcement fillers can be identified. So you have the flax, sisal, wood pulp. If you go to the other portion, you have the wheat, the corn, the miscanthus, right? It comes under the agro and forestry residues. In the case of traditional natural fibers, we have the kenaf, flax, jute, sisal, rami, cotton, bamboo, henequin, and wood. Of course, industrial products also, which are widely used as reinforced materials like the lignin, the DDGS, biocarbon, pomace. The pomace is actually a product of the oil that is coming from the olive. I think most of the Middle East countries are much more familiar with the pomace. This is also another residue that comes out. It is an industrial co-product that can be used as a reinforcement. The other portion, you have the recycled fibers like the carpet, the cardboard, and even the carbon, like carbon carpet mats, wooden pellets, cardboard sheets, carbon fibers. These are all very common applications that you can see. So when it comes to the natural fibers, see what I'm trying to give. We are done in this particular review paper is we are trying to throw some light on the importance of green composites by introducing what are the different types of fibers that are used, and then we have moved to the other aspect of how green composite is going to replace the metal matrix composite genre, and not only that, how well the green composite is going to be an environmentally friendly material when compared to the other non-biodegradable materials. So when it comes to natural fibers, of course, the wood material is a multi-layered organic composite, rendering it incredibly robust. Even the wood pulp too is utilized in the manufacture of course, the composite reinforcement. The other common organic fibers, we know that although it has poor mechanical characteristics over the synthetic materials, such as Kevlar and aramid, however, this weakness can be overcome by enhancing the density of the organic fibers. So when you say organic fibers, they have some tremendous advantages over the synthetic fibers, including the recyclability. It has very good biocompatibility, environmental friendliness, superior insulating characteristics, and reduced machinery wear. And the natural fibers may be able to replace the synthetic fibers in the near future, provided their moisture absorbing characteristic is pretty lowered, and even the fiber lengths are extended to improve the mechanical characteristics. When it comes to the plant fibers, of course, we know even the residues like the leaves, the fruit stems, straws, and grasses, they're all studied in detail by numerous researchers. And natural fibers, on the other hand, have several drawbacks when compared to synthetic fibers, such as a product variance owing to factors such as the plant age, the climatic and the geographical growth circumstances, the cultivation techniques, and the cleansing technologies. So all these things we have to consider while manufacturing the green composites, right? So these are some of the natural fibers like rice husk, palm, the cotton, chicken feather, banana, even the leaves, banana. The peel also can be used. The jute, the kenaf, the coir, abaca, hemp. So these are some of the natural fibers, which is giving a very tough competition to the synthetic fibers like Kevlar, glass, basalt, and carbon. So these are some of the tremendous properties of the natural fiber. Of course, these are some of the factors that must be considered before this natural fiber is used as a viable replacement for the synthetic fibers. So you have the good moisture absorption, fiber orientation, renewability, reliable supply chain, the porosity part, the swelling effect, even the wettability are some of the features that we have to look into. So this is the natural fiber. Already we have covered the man-made fibers and the natural fibers, the cotton boil, jute plant, ramie. It comes to the animal part. We have the silk cocoon, we have the camel, the spider silk, wool, and mohair. And comes to the man-made fibers, the polymer and mineral. You have the fiberglass, carbon, acrylic, polyester, nylon, spandex. Okay, and this is the animal fibers which already we have covered. For example, the chicken feather fibers extensively available throughout the world, as chicken is one of the most widely consumed foods. Coming to the application part, that is something that we have to give some importance. Let me come to the applications, and I will come back to this. So these are some of the very important applications of polymer nanofibers. For example, it's used for the cosmetic skin masks, the application in life science, the drug delivery carrier, like a hemostatic devices, wound dressing, it is used. Of course, the tissue engineering and scaffolding, the porous membrane for skin, tubular shapes for blood vessels, and nerve regenerations. And the other industrial applications such as the macro nano electronic devices, the electrostatic dissipation you can see. So all these things are some very important applications of the polymer nanofibers. So coming to the significant applications of the green composite made from the structurable raw materials, that is, you have the nanofibrils. So in the case of medicine, cosmetics, the energy, electronics, environment, and textiles. Because the medical field, they can be used as, of course, the medication carriers for prostheses, bandages, surgical materials, and so on. So these are some of the facts, because I've been given a very short time. Because although the review paper, we have covered many important aspects related to the significant applications of green composites. Of course, in the case of C, the other applications are the plant fiber-based reinforced composite, like the boat hulls, the canoes, skateboards, surfboards, bicycle frames, sports rackets, dolls, music equipment. These are some of the important applications of the green composite made from the sustainable raw materials. So what about the recyclable ones? So the recyclable material, indigenous resources, construction and materials reclamation are also included in green composites, architectural as well as the structural applications. And the green composite bars have been very commonly used in construction to substitute their conventional steel bars, resulting in structures that are significantly earthquake resistant. These are some of the most common applications of, I think we are already aware. The most common one is the healthcare, the prosthetic foot, hip prosthesis, cervical flat implant is a very significant application of the green polymer-based composite materials. And the automotive applications, the bonnet, door panels, boot liner, headliner panels, even a military helmet is also another significant application of the green polymer-based composite materials. And this also, I think most of us are already aware, the low-load drag electric race car is also made of the green composite. In other words, the recycled carbon fiber composites are used for the structural parts. Even the flax reinforced composites are also used to manufacture this particular sports car. Even the low-load racer, the B690 EV, of course, this is also another significant area where the green composites are used. So these are some of the other applications you can see on your screen. You have the floor carpet. You have a car, the pad and racer, the dash engine, room insulator, the accessories mat, the protector wheel house, the trunk and luggage floor, of course, the partial shelf on the trunk and luggage side. These are some of the important applications of the green composites. So what about the concerns in the production of green composites? So far, we have seen the advantages, but there are some issues related to the concerns that we have to face. The very first thing is the heat treatment issue. So heat treatment is no doubt a major stumbling block that is coming in the way of the smooth manufacturing of the green composite materials, because the fundamental issue in green composite manufacture is that they may survive extreme heat while removing the odor produced by the natural fibers such as the kenaf, hemp and jute. So the natural fiber-based composites are of course quite expensive, which is not acceptable to the massive car sectors. So not only the other drawback is the insufficient knowledge about the functioning of the sustainable and green composites, owing to an enormous diversity of ingredients, is the greatest difficult hurdle to surmount in this industry. One more thing is, not to achieve the good quality composites, the first essential task is to choose the correct manufacturing circumstances and the factors, as well as the precise choice of the composite ingredients and overall material qualities. The other one is the recycling of the discarded composite materials, of course, towards expiration of its functional life, should be regarded throughout the design phase of the product, because the plastic trash has indeed been identified as a significant environmental issue, and consumers, of course, have expressed deep worries about the discharges of these contaminants and the chemicals in the plastic consumer goods. And even the plastics are somewhat, of course, inevitable materials in many aspects of modern civilization, including the medical services, distribution of food, construction materials, automobiles, and even the mobility, and even the wrapping for the household devices. So material reclamation is another factor that has to be considered. That is both ecologically good and technically effective, should also be implemented, particularly in countries that are overpopulated, like India, China, countries like Indonesia, where population is a major thing. And one more thing I want to cover is, sir, can I cover for another 3-4 minutes, sir? Can I talk for another 3 minutes?
ثانك يو بروف عبد الرحمن، شكرا جدا للعرض الكويس.
اوكي سر.
اني كويشن، يعني هنسيب مجال خلصت كده بروف ولا لسه؟ نو يو كان اند.
I can end, or can I proceed, sir? Okay, sir.
Okay.
So some of the slides I thought of covering, but because of the time limitation, okay, sir. And there is also one more presentation I would like to do. on the effect of fabrication parameters on the mechanical wear and corrosion behavior of hybrid metal matrix composites. Recycling of MMC, a review. Can I make the second presentation, sir?
حد عنده أي أسئلة يا جماعة؟ طيب متشكرين جدا بروف عبد الرحمن. Thank you for you.
Second.
The second paper ID. You can start. You can start, Prof. Abdul Rahman. You can start.
Yeah, second presentation, sir. Can I start, sir?
تفضل. You can start.
Okay, sir. Sorry. Thank you, sir. Is my screen visible? Okay, coming to the effect of the second paper which we would like to present. It is on the effect of fabrication parameters on the mechanical wear and corrosion behavior of hybrid metal matrix composites, recycling of MMC, a review. Okay, this is a very important topic where the production of MMCs, when you see, it consists of course, we know. Let me just touch the basics before I get into the actual content. So the MMC, we know that consists of a base metal matrix with a ceramic reinforcement, and we all know that the MMCs have replaced the traditional metal alloys in many applications such as marine, aero, auto, sports, recreation industry, and even the medical field. So a perfect combination of properties such as high specific strength, thermal resistance, and superior wear resistance, low coefficient thermal expansion, good damping capacities, and corrosion resistance and superior stiffness can be tailor-made in the case of the metal matrix composites. So due to the desirable qualities like reduced weight, even the improved strength, excellent thermal stability, resistance to corrosion, the hybrid metal matrix composites have gotten significant attention. And even there is even advancement to the traditional metal matrix composites in which more than one variety of reinforcement of varying shape and size is employed to improve the specific characteristics. And the main objective of this paper is to the review of the 3 articles, discuss the diverse combination of the strengthening media, so including both the inorganic and as well as the organic reinforcements such as the coconut shell ash, bamboo leaf ash, rice husk ash, and aloe vera, and even the other fabrication methods that are carried out will also be covered. Even a comprehensive comparison study for production of MMCs is also present in this article, in which several modern organic and inorganic reinforcement and base materials, including some significant advancements in the latest research works, are also extensively examined. So this is the very basic outline of the various classification of the various production methods that are followed to produce metal matrix compound. Of course, the most common is you have the powder metallurgy, you have the mechanical alloying, sintering, mixing, mechanical alloying, blending of powder and hot pressing, spark plasma sintering, deformation processing of powder compacts, you have the melting and solidification, the thermal spray, like the plasma spray, you have the cold spraying, even the electrochemical deposition, and the latest novel techniques like the molecular level mixing, the sputtering techniques, sandwich processing, and vapor deposition, mixing as paste, nanoscale dispersion. These are some of the most commonly adopted manufacturing routes. Let me just show some of the the schematic sketches are the various. This is a very simple steel casting setup that is used. We have the liquid infiltration and liquid metal infiltration setup that is also commonly used. And we know this is the basic outline of how a powder metallurgy works. So this is a powder metallurgy process. You have the friction stir welding and Coming to the various, how the composite materials are basically classified. So it is classified into three major classifications based on the matrix, based on the reinforcement, based on the interface. So based on the matrix, you have the polymer matrix composites, you have the metal matrix composites, and the ceramic matrix composites. And if you come under the polymer matrix composites, you have thermoset, thermoplastic, and rubber. Now, another very important thing is the type of reinforcement that is used. You have the alumina, you have the silicon carbide, boron carbide, the titanium carbide, tantalum carbide. That is, in other words, the combination of oxides, borates, and carbides are generally used as synthetic reinforcements to improve the strength and the other properties like tribological properties and the corrosion properties of the metal matrix composites. And this is the very mostly commonly used synthetic reinforcements. You have the magnesium oxide, zirconium silicate, you have the zirconium oxide, the titanium boride, silicon carbide, boron carbide. These are very commonly used synthetic reinforcements. So what about the organic reinforcements? How the organic reinforcements are classified? Of course, industrial waste, agro waste, you have the polymers waste. So under the industrial waste, you have the most common red mud, coal fly ash. See, many research works have been carried out after reinforcing the metal matrix with the organic reinforcements. How the mechanical behavior is being affected, how the corrosion behavior is affected, how the wear behavior is affected. Many research works have been carried out, and it was found really satisfactory that organic reinforcement could be a very good replacement for the synthetic reinforcements. So these are some of the research works that have been carried out. For example, Al-Sadi et al. Investigated the mechanical characteristics of polyester matrix composite with microscale natural. The pistachio shell. Pistachio means you're talking about the commonly used pista. That is a shell material that is used for to enhancing the properties like the flexural strength, tensile strength, and the impact strength. And you have the even the hybrid egg shells are also used. Imagine some hybrid composites are also made by using the egg shell in collaboration with the silicon carbide and as well as alumina. You have some good decline in porosity up to 75%, a 76% decline in the residual stress, 83% improvement in the micro hardness, and 107% improvement in the micro hardness under a stirring time of 6 minutes has been achieved. Even the BLA is also another important reinforcement that has been used along with alumina, and studies have revealed that the tensile strength, yield strength, and specific strength are also have been improved because of the addition of the organic reinforcements. We have many research works. Only a few I have shown in my presentation. So you have the rice husk ash. Even the rice husks are also have been included to the 6061 6S aluminum alloy, which acted as a nucleation source, resulting in finer aluminum matrix gains, and even the wear resistance, in addition to the increasing the mechanical characteristics, have been achieved. And you have the Alanim et al. 2018 documented investigation connected to research the fracture mechanism, mechanical and microscale characteristics of aluminum matrix composites strengthened by silicon carbide, and even the groundnut shell ash particles have been used. So some very good improvement in the fracture toughness have also been documented. Even the aloe vera powder has also been used to study the mechanical behavior of aluminum metal matrix composites by Hima Girish. And even again, Alenema and Adivel in 2003 investigated the mechanical properties of 6063 hybrid composites strengthened with 575 and 10% of silicon carbide. Of course, significant improvements in terms of improved tensile, yield, and specific strengths have been observed. So what about the recycling aspect? Of course, recycling is a very, very important topic where because of the ever increasing number of agricultural and industrial waste products, raises environmental pollution problems such as, of course, it poses the risk of poisoning in people and animals and also plant contamination. So furthermore, irrespective of area, the global consumption levels, if you see, have already had a substantial influence on the environment. So recycling is a process of course, removing the goods from the trash stream so that they could be utilized as raw materials in the development of innovative products. So what happens as a result of recycling can be of course two. One is the recyclables could be used directly or the waste products can be employed as raw materials for the new items. So these are some of the research works carried out by P.S. Ling and M. Gupta, investigated the possibility of recycling a silicon carbide particle reinforced aluminum composite, and it was found that there has been a significant improvement in the ultimate tensile strength. Even the ductility and other mechanical properties have found to be significantly increased. Okay, even the Oshikawa et al. Used aluminum lumps and the soda lime glass beads as raw ingredients to manufacture the aluminum and alumina metal matrix composite. Even here also, if you see, the compressive strength has been significantly improved because of the addition of the aluminum lumps. So I can give you many such what you call importance of course, the significance of addition of the organic reinforcement as well as the recycling of MMC, which is very, very important. So in conclusion, I would like to conclude that the numerous different kinds of hybrid reinforcements have been suggested in various production processes. So excellent mechanical wear and corrosion properties of the hybrid MMCs make them among the most advanced materials employed in the automotive, aerospace, and the structural as well as the medical industries. And the impact of various hybrid reinforcing media on the mechanical wear and thermal and electrical characteristics have now been really thoroughly studied, and it has proved that it really plays a significant role in improving the mechanical corrosion and wear behavior of the metal matrix composites. And what about the future scope? So in the case of future scope, let me add a few words that the present review paper suggests that the hybrid metal matrix composites based on the nano and biomaterials are evolving sectors that can be effectively used in automobiles, maritime, aviation, wind electricity production. And the hybrid thermoplastic and hybrid structural composite materials can also be used in the field of civil engineering, biomedical engineering, as well as other affiliate industries, despite significant work in this particular domain. So more such research works can be really carried out, and what do you call the hybrid metal matrix composites can still be implemented in areas where we can even focus on the nano-based hybrid metal matrix composites. Thank you, sir. Jazakallah khairan.
Thank you for good presentation, Prof. عبد الرحمن. بنشكرك جدا جدا على العرض الكويس ده والجيد جدا.
Thank you, sir.
Any question? حد عنده أي أسئلة؟ Any question?
No question.
No question. تمام كويس. نبدأ إن شاء الله في البيبر 3. بروف قنديل متواجد. Performance enhancement of. اتفضل. You can start.
Okay, speak in Arabic or English?
اللي يعجب حضرتك. عايز عربي ما فيش مشكلة، انجليزي ما فيش مشكلة، اللي يعجب حضرتك. عايز تنوع ما بين الاثنين ما فيش مشكلة. المهم الوقت بس نرجو الناس تلتزم بالوقت. 10 دقائق في البرزنتيشن ونسيب من 3 دقائق ل 5 دقائق للايه للأسئلة. اتفضل بروف. اتفضل بروف.
اوكي، السلام عليكم. انا اسمي عبد الله وجيه قنديل. اليوم اقدم عرض عن شغل بحثي بعنوان Performance Enhancement of a Solar Desalination System via External Condenser, Thin Film Evaporation and Reflectors. This work was authored by me, Abdullah Khan, Professor Mshashir, and Professor Noyang. The presentation will be in 6 outlines. First is the background. I think all of us are aware of the problem of freshwater shortage, as only 1% of the water is drinkable. This problem is increasing with the industrial growth, population explosion, and pollution problems. But the Earth is very lucky because of the availability of solar energy. The solar energy is available approximately on all the Earth's surface, with daily energy about 7.4 kilowatt per meter square per hour. This is a great opportunity for solar desalination system, especially solar still. Solar still is a simple device that consists of basin which contains saline water that evaporates under the solar radiation. Then it's transformed to the inner surface of glass cover to be condensed and is collected as fresh water. Solar still has many advantages such as simplicity, easy operation, low cost, but it has disadvantages of low productivity and low efficiency. So many efforts have been conducted to enhance the productivity and efficiency. To enhance the productivity and efficiency, we should know what is the affecting parameters on the performance of solar cell. According to a machine learning work, it was proved that the thermal design is the most important parameter that affects the performance of solar cell. So approximately all the efforts conducted to enhance the solar cell performance was conducted to enhance the thermal design. Now I will give a literature review. There are many designs of solar cell. This design, which was presented as single slope, it was updated at double slope solar cell, pyramid solar cell, hemispherical solar cell, and tubular solar cell. We can see from these numbers that enhancing the thermal design can enhance the productivity and the efficiency, but also it's still low. So further enhancement can be conducted, such as integrating heat localization material. The aim of heat localization material is to localize or concentrate the heat on the surface of evaporation without the need to heat black water. In this work, a plastic ball was used as insulation. It was covered with wick to having a good capillarity to rise the water to the evaporation surface. The productivity and efficiency were enhanced by 60% and 32% respectively. Also, the performance can be enhanced using condenser. The condenser aims to increase the condensation rate of the vapor. In this, the condenser can enhance the productivity and efficiency about 78 and 32% respectively. Besides, reflectors can be added to concentrate the solar radiation on the evaporation surface to enhance the productivity. In this work, the productivity was enhanced by more than 165%. The objectives of the current work is to enhance the condensation process using integrated external condenser, and enhance the evaporation process using heat localization material or interfacial layers, and the concentrating the radiation via reflectors. Our system consisted of conventional solar cell for comparison and the modified solar cell. The modified solar cell was integrated with reflectors, external condenser, and also integrated with heat localization material. The whole system was provided with saline water through a tank and connected with pipes and fitting valves and others. The condenser, the used condenser was a passive condenser that consisted of helical coil and finned with radial fins, about 8 radial fins. The water was stagnant in an external shell. The heat localization material was a foam layer, foam strips, covered with close wick material with high capillarity, and we used also graphite particles on this surface, dispersed on the surface of the heat localization material. The result showed that the heat localization material worked successfully as the heat was localized on the surface. The highest temperature was that of heat localization material, while the lowest temperature was the water of the modified solar cell. This means that the heat localization material successfully matched the purpose of using. Also, the gross temperature of the modified solar cell was higher than that of conventional. This is reasonable because the higher temperature of the vapor due to the high temperature of the localization material in the modified solar cell. We can see the advantage from this comparison. The water temperature in the modified solar cell was very low, while the heat localization material temperature was very high. The productivity was enhanced. It was always very high for modified solar cell compared to the conventional solar cell. The accumulated productivity at the end of the day reached about 3.76 for the modified, and it was about 2.93 for the conventional solar cell. This means that the enhancement percentage reached about 28.3%. When addition of the reflectors, we can see that the heat localization material in the modified solar still temperature was much higher than the previous because of the concentrated solar radiation due to the addition of the reflectors. We can see this temperature was raised to about 63, whereas the modified solar still water was 34. This means that the heat was successfully localized on the surface. This is followed by a very good enhancement in the productivity. The productivity in the conventional solar still was about 2.9, where it reached 4.81. This means that it was enhanced by 66% enhancement. Also, we conducted a thermoeconomic performance assessment in terms of the energy efficiency, which is a function of hourly productivity, latent heat, solar radiation, and the area and work fan of the used fan for the condenser. The economic analysis was conducted by calculating the cost of the produced water, which is a function of the annual cost, daily productivity, and number of days, interest rate, and the number of years. The thermoeconomic performance showed that the conventional solar still efficiency was about 4, where it was enhanced to 41 and 56 in case of the modified solar still with condenser and heat localization, and with condenser, heat localization, and reflectors. Whereas the cost was reduced by addition of the proposed modifications. To conclude, the solar still performance was enhanced via integrating external condenser, heat localization material, and external reflectors. The major results can be concluded as follows. Using a condenser heat localization material, which is known as modified solar still number 1, the productivity and the efficiency was enhanced by 28.3 and 21.3 respectively, and the freshwater cost was saved by about 5.4%. Using condenser, heat localization material, and the reflectors, the productivity was enhanced by about 66 and 65 respectively, and the freshwater cost was saved by about 20%. At the end of this presentation, I want to say thank you to my professors, Professor Nguyen, also the Professor Dr-Nouby and Dr. Swaylam for their continuous help, encouragement, and support, and also great thanks for Nano Heat Group, and thank you for your listening and looking forward for your valuable comments and recommendations. Thank you for all.
Thank you for good presentation, Prof. Qandil. Any question?
دكتور عبد الله.
Any question? حد عنده أسئلة؟
شكرا دكتور عبد الله، مقدمه لذيذه وبرزنتيشن هايله بصراحه. دكتور ايمن شكرا. اسمح لي بس بالمداخله ديت. هو البحث بالفعل عليه دكتور عبد النابي ودكتور سويلم، دكتور سويلم ودكتور عبد الله. دكتور عبد الله يعني بسم الله ما شاء الله عليك، يعني in Arabic احنا بنقول بس it is very good interest, very good paper and perfect presentation. Your topic is very important nowadays, and I think Mr. Dr. Swaylam have new school like Dr. Dr-Nouby Qabil. Yes. And in the future, Dr. Abdullah, you will follow your Professor Dr-Nouby and Swaylam. شكرا لك يا دكتور عبد الله.
Thank you very much.
لأنه هو البحث حابب أكلمك بس خاص، لأنه عايز أشوف بس دكتور قبيل فين في البحث. دكتور أيمن بيقول دكتور قبيل كل شوية.
قنديل مش قبيل.
قنديل تمام. لأن دكتور عبد النبي دكتور عبد النبي قبيل كان المفروض يبقى هو رئيس سيشن وهو معانا تمام.
لا أنا أقصد بروف قنديل.
ودكتور سويلم. السلام
عليكم.
عبد النبي قنديل.
تمام.
السلام عليكم.
قنديل مش قبيل، قنديل.
السلام عليكم.
وعليكم السلام.
السلام ورحمة الله وبركاته.
الله يعطيكم العافية جميع المتحدثين. شكرا لهذا البيبرز الموجودة والتقديم الواضح. الحمد لله رب العالمين. أنا دكتور صهيب، تخصصي statistics يعني إحصاء تطبيقي. فحبيت أسأل بالنسبة الجانب الإحصائي لجميع الأوراق، يعني يعني كان في دراسات يعني على الجانب الجدوى بالنسبة للجدوى والكواليتي بالنسبة للجانب الإحصائي على الأثر في الدراسة، في كل دراسة، في كل ورقة مقترحة. والسؤال الأخير بس حاب إني أعرف، أنا مشارك يعني معكم، في شهادات يعني إذا كان في شهادات للمؤتمر؟ يعطيكم
في
العافية.
شهادات ان شاء الله يا دكتور صهيب، في شهادات. حضرتك تتواصل معانا، حضرتك سجلت على جوجل فورم دكتور صهيب؟
لا والله ما سجلت، لا والله ما سجلت، لو تبعتوا لي
طيب
اللينك.
دكتور صهيب، انا هو احنا قفلنا باب التسجيل، بس ما فيش مشكله طول ما حضرتك حضرت معانا النهارده، احنا ما فيش اي مشكله. ابعت لي بس بيانات حضرتك، هبعت الايميل وابعت لي بيانات حضرتك، وان شاء الله في شهادات
إن شاء الله.
ماشي. شكرا يا دكتور عبد الله، شكرا دكتور ايمن. اتفضل دكتور
اتفضل
ايمن.
سعادتك.
اتفضل يا
اتفضل
فندم.
سعادتك. ان شاء الله البيبر رقم 4 بروف كساب، مظبوط الاسم ولا؟ بروف كساب.
مظبوط يا فندم.
اتفضل تحت، اتفضل يا فندم.
السلام عليكم جميعا. Good afternoon
السلام
everyone.
عليكم.
We are going to share now. Thank you for attending my presentation. We are going to present now the paper for influence of the flange height on the diffuser augmented wind turbine structure. This is presented by me, Engineer Ahmed Usama, and was supervised by Dr. Sadiq Kassab and Dr. Amr Abdelrazak. First of all, in order to introduce a small introduction regarding the wind energy. Wind energy is considered one of the most plentiful renewable resources, and it has been used since for more than 4,000 years in daily works. It was named as windmills.
سرور فرغينا ذناك احنا.
نعم.
اتفضل سعادتك، اتفضل.
Okay.
نرجو الناس بس تقفل المايك.
Okay. Figure number 1 shows some samples and examples for the windmills that used in the
سرور
past,
غسل يديكي
in the early years.
الجميع يقفلوا المايك يا جماعه، تقفلوا المايك.
بروف احمد اسامه، نرجو
أيوة
حضرتك تقفل المايك. تقفل المايك.
هو انا اللي بتكلم.
اتفضل. طب اتفضل يا فندم.
Figure number 1 shows a sample and examples for the windmills used in the early years, and figure number 2 shows some patterns for the prevailing wind directions all over the world. For the prevailing wind, it is the wind direction that is mostly common in most days of the year. So these are the patterns of the directions of the prevailing winds. In case if we are going to generate electrical power from wind energy, we shall utilize and use wind turbines. Wind turbines, after several experiments, have concluded that the optimum wind speed that we can generate at wind energy, electrical energy, is at 12 meters per second. There is a power equation shown here that shows how to generate power from a wind turbine, where PT is the power of the extracted from the wind turbine equals half CP. This is the power coefficient of the wind turbine multiplied by A, which is the cross-sectional area of the wind turbine, multiplied by rho. This is the air density, then multiplied by cube of the wind velocity. Just to highlight that the cube of the wind velocity, which means that if we have, as an example, 2 meters per second, then it will be 8, and then multiplied by other factors. This is the wind atlas of Egypt that shows that the wind velocity ranges between 4 and 11. The highest wind speed is in Suez Gulf, which ranges between 7 meters and 10.5. In our study, we took an example of wind at Alexandria, which ranges between 4 and 6 meters per second, having a mean velocity of 5 meters per second.
باشمهندس احمد السلايدز مش بتتحرك بس خد بالك.
طب كده واضحه ولا؟
هي ما بتتحركش، يعني انت حضرتك واقف على الشريحه الاولى ما اتحركتش، رغم ان حضرتك بتتكلم دلوقتي تقريبا في الشريحه رقم 5 أو 6.
طب هي كده ظاهره؟
هي كده بتظهر تمام كده، تمام. اتفضل 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 يا بروف.
تمام.
اتفضل يا باشمهندس احمد.
اوكي شكرا. Figure number 4 shows a diffuser, the structure that we shall reach with by using it the required and the optimum velocity, or approach this optimum velocity, which is 12 meters per second. This is the diffuser, the flanged diffuser augmented wind turbine, where this figure shows the pattern of the air and the wind passing through it, where it passes in a uniform phase in the beginning of it. Then there are some eddy currents behind the flange, which acts as a suction area in order to increase the velocity inside the structure. This figure shows the wind comparison between wind velocities inside the structure. The lowest one when we use only diffuser, the second one when we use only diffuser with a flange, the third one is diffuser with nozzle, and the most optimum and the largest wind value inside the structure when we use nozzle, diffuser, and flange. This figure shows the power coefficient of the wind turbine when we used a flange diffuser and when we don't use a flange diffuser. There's a major difference between them, and which results in a major difference in the resulting power. Our present study handled mainly two methodology. The first methodology is that we have several controlling parameters, as shown here. This is the nozzle, the beginning of the structure. Here, can you see my screen now? The structure, figure number 7.
واضحة باشمهندس.
تمام. Okay. Figure number 7 shows the nozzle. There is a nozzle length and angle, diffuser length and angle, and this flange height. So our first methodology was to fix all the 4 parameters and only change the flange height in order to conclude the best value of the flange height. So these values were concluded from other experiments. Having these values for the nozzle length was 0.25D, nozzle angle 22, diffuser length 1.45D, diffuser angle 12. Then we changed the flange length in order to conclude the best length. The values that were carried out was from 0 to 1.25D. And these were the outcomes by using ANSYS Fluent software. Okay. This first figure was without using a flange, with HF value equals 0. The second one is 0.5D, 0.6D. These are the velocity contours, velocity curve, pressure contours, and pressure curves. This for 0.5D, this for 0.6D, 0.7D, 0.8D, 2.9D, and D. This for 1.1, 1.25. So after calculating and these figures and this shape through ANSYS software, we concluded that the flange height from 0 to less than 0.5D is not recommended, as the solution did not converge, where the optimum and the highest wind speed was at a value of D equals 0.5, which give us a velocity ratio 1.76. Okay. And the lowest one was at D was 1.25. This was the highest pressure, highest velocities at the throat of the structure, whereas you can see that the highest one is at 0.5D. The second methodology that we used is that we made the 5 controlling parameters. We changed them, all of them at once, and we carried out more than 30 random cases by changing all parameters with each other in order to conclude the best shape of this structure. These were the values for the nozzle angle, the diffuser length angle, and flange height. We changed all these values together randomly, and this method is called design experiments method in order to conclude the best and optimum shape. After carrying out these 30 models, we concluded that the highest wind speed was generated at a flange height of having 0.9 d with a power factor of, with a ratio between inlet velocity and the velocity inside the throat of the diffuser at a factor of 1.83. And the lowest one was at 1.25 d. This was the graph showing all the trials in blue dots, where it is clear that at 0.9 d, it is the highest velocity with a factor of 1.83. In conclusion, this paper shows that the high effect of using a flange at the diffuser structure, which increases the velocity in a high manner inside this structure. And in addition to that, it shows the difference between the two methodologies, where when we fixed the other parameters, we give us the flange height with 0.5 d, while when we use design experiment method, it gave us the most optimum value at 0.9 d. Thank you.
شكرا جزيلا باشمهندس احمد. شاكرين جدا على انهائك العرض في وقت مظبوط. ونفتح المجال للاسئله. Any question? حد عنده اسئله؟ Any question? Thank you for good presentation مهندس احمد. البحث اللي معانا بعد كده نرجو نشغل المايك يا جماعه. اسماء محمد. بروف اسماء قائمه.
دكتور علي.
ايوه موجود.
اتفضلي. البحث رقم.
دكتور ايمن لحظه ممكن؟
اتفضل تحت امرك.
لسه في مايكات كانت مفتوحه حاليا يا دكتور، ففي تشويش جامد بالنسبه للمايكات.
نستأذن الناس اللي هي فاتحه المايك تقفله. الناس اللي فاتحه المايك نستأذنهم يقفلوا المايك. ماشي، متشكرين جدا لساعتك دكتور حاتم.
الله يبارك.
الناس اللي فاتحه المايك. بروف شيت، بروف لونج شيت، نستأذنك تقفل المايك. طيب عشان ما نضيعش وقت حضراتكم، البحث رقم 5 ID بروف اسماء طعيمه.
ايوه مع حضرتك. تمام.
اتفضلي حضرتك، اتفضلي. مع حضرتك 10 دقائق للعرض، وهنسيب من 3 دقائق ل5 دقائق للاسئله.
خلاص تمام.
اتفضلي بروف اسماء.
Hi everyone. Today I am going to present a research from my master's thesis. It is
in Arabic or English?
In English. تمام. ابتدي.
اتفضلي عربي او انجليزي، اتفضلي ما فيش مشكله، اتفضلي.
اوكي ماشي.
Hi everyone. Today I am going to present a research from my master's thesis. It is titled Transfer at a corrugated wall of a square stir tank reactor. All of the authors are associated with Alexandria University Faculty of Engineering in Egypt, from both chemical and mechanical engineering department. I am the corresponding author, and you can direct any question to my email, which is presented on the slide. Outline of this presentation is the introduction and background, research objective, experimental procedure, result and discussion, and finally conclusion. First of all, it is an introduction for my research. Chemical reaction can be classified as homogeneous or heterogeneous chemical reaction. Homogeneous reaction occur uniformly through one phase. However, heterogeneous reaction takes place in 2 or more phases. Such reaction involve at least 2 steps. The first one is the diffusion of the reactant from the solution to the solid surface. This is step known as mass transfer step. Finally, chemical reaction occurred at the solid surface between reactant. This reaction occurred in stirred slurry reactor, which is used widely in manufacture of fine chemicals and drugs. A stirred slurry reactor has a lot of advantages. However, the disadvantages are the catalyst for a slurry reactor becomes ineffective due to continuous circulation. A scaling up of the reactor poses several problems. The most serious shortcoming is that separation of the catalyst from the product is a time-consuming process and need a high cost. The aim of the present work is to increase both the rate of mass and heat transfer in a squared stirred reactor by increasing the surface area. This can be done by fitting the inner side wall of the tank by a V-corrugated sheets, which acts as a turbulent promoter. Experimental steps. This research has been done experimentally on this slide. I will go on in brief through the component of this trick in the following.
نرجو الناس اللي فاتحه المايك. شهاب سعود الناس اللي فاتحه المايك نرجو بتقطعوا الناس.
The main component is the squared stirred reactor with a dimensions 15 by 15 by 25 cm, which is made of plexiglass. Using two different impellers, the first one is the axial flow turbine and the second one is radial flow turbine. I used 5 cassettes, 1 smooth surface and 4 corrugated. All cassettes are made of copper plated with nickel with dimensions 15 by 15 cm. I kept the groove angle constant and used 4 different peak to valley height, which is 0.2, 0.5, 0.75 and 1.5 cm. A multi-sheet of stainless steel with a mesh number 12 is used as anode with a dimensions 15 by 15 cm. Also 30 volt DC power supply is used. 2 avometers are used, one as a meter and the other as a voltmeter. The steps of the experiment is as follows. First, I prepare 3.4 liters of the first solution containing 0.1 molar potassium ferrocyanide and 0.01 molar potassium ferricyanide in a large excess of sodium hydroxide, which concentration varies from 1 molar to 3 molar. Temperature was maintained at 25 degrees Celsius by inserting the cell in water bath fitted with a thermostat. Physical properties of the solution is obtained from the previous studies to calculate Schmidt number. The rate of mass transfer was obtained using electrochemical technique in which the limiting current of the reduction of ferricyanide at the cathode surface was obtained from the polarization curve that constructed by a stepwise increase of the current and measure the corresponding zip voltage until the plateau of the limiting current is reached. Mass transfer coefficient is calculated from the limiting current equation as follows. IL is the limiting current, Z is the number of electrons involved in the reaction, C concentration of ferricyanide ion, A is the surface area of the cathode, and finally K is the mass transfer coefficient. Mass transfer correlations is obtained using some dimensionless group as follows. Reynolds, Schmidt, and Sherwood, where Rho is the density of the solution, N is the RPM of the impeller, and Di is the impeller diameter, and mu is the viscosity of the solution, D is the diffusivity of the solution, and L is the length of the cathode. For the flat wall, these figures show log Reynolds versus log Sherwood at different values of Schmidt number. As we see, there is a direct relation between log Reynolds and log Sherwood at constant Schmidt. Also at constant Reynolds, there is also a direct relation between Schmidt and Sherwood. The data fits the equation Sherwood directly proportional with Reynolds to the power 0.55 for radial flow impeller. The same trend was found for axial flow impeller. Under the operating condition, overall mass transfer correlation was obtained from this chart. The same trend was found in case of axial flow impeller. For a given set of conditions, it was found that radial flow impeller gives a higher rate of mass transfer than axial flow impeller. This is because a jet produced in radial flow impeller which hits the surface. This jet has a great effect on the rate of mass and heat transfer. This figure shows that corrugated surface enhances the rate of mass transfer, which is expressed in terms of volumetric mass transfer coefficient by factor ranging from 1.1 to 3.7 compared to a flat wall for radial impeller. This result was found due to separation of the diffusion layer and the formation of the circulating eddies at the upper part of the grooves. This figure shows the effect of the peak-to-valley ratio of the corrugation on the rate of mass transfer. As the value of it increases, the rate of mass transfer decreases as the circulation eddies don't reach the lower groove region. Under the operating condition, overall mass transfer correlation of stirred tank reactor with a corrugated wall is obtained. Overall heat transfer correlations can also be obtained by analogy between mass and heat transfer. Finally, this work developed a heterogeneous stirred reactor whose side wall can be employed as a surface reaction, where diffusion-limited catalytic reaction can take place to overcome the drawbacks of stirred slurry reactor. Corrugation were found to enhance the rate of mass transfer by a factor ranging from 1.1 to 3.7 compared to the flat wall. For a given set of conditions, radial flow turbine gives a higher rate of mass transfer than axial flow turbine. Thank you for your attention and
شكرا لحضرتك.
شكرا جدا بروف أسماء، متشكرين جدا. Thank you for good presentation. Any question؟ حد عنده أسئلة؟